So, starting off with direct variation, I'm going to give you some high points, some low points. We're not going to go through this entire set of notes. We're just going to do as much as we can, and then I'll kind of take questions as I see fit, and I'll go from there. Direct variation is a specific relationship in which there is a constant relationship between all ordered pairs. Okay, let me ask you this question. Now I'm going to make you dig a little bit on this one. So if you don't know the answer, don't take it personally. If there is a constant relationship between all ordered pairs, every single one, what does that mean that we don't have? There's a constant relationship between all ordered pairs. What does that mean that we don't have? Think about it. It's a vocab word from last unit. If every single ordered pair has a relationship, what do we not have then? Every single ordered pair has a relationship. What do we not have?
Oh, we do not have non-functions.
I agree, it will be a function. I agree, you're not wrong on that. All right, let me ask you this. If I tell you, you go to a Rangers game, and at that Rangers game, every single ticket costs $20, but you have to pay for parking. Doesn't that parking change up the fact that I have a consistent relationship between every single ordered pair? So I don't have a y-intercept. Very good. Now think about that for a second. I'm just going to draw this brief graph here. If I have to start from this point, doesn't that mean that I'm totally shifting the entire constant relationship that's over and over and over because I have to add that number at the end every single time? Let me show you what I mean by that. If I have y equals 2x, what's the relationship? Times 2. Every single time it's times 2, it's times 2, it's times 2. So it doesn't matter what number I give you, you're multiplying it by 2. Doesn't matter what number Abby gives you, you're multiplying by 2. Doesn't matter what number Zandon gives you, you're multiplying by 2. But then, if I were to have y equals 2x plus 5, I'm changing it up because I'm now multiplying and adding 5. Long story short, this is not a proportional relationship because that plus 5 is skewing my data. That plus 5 is changing what I'm trying to do. Okay? So the question is, how do we find the constant? Direct variation equations are written in the form of y equals kx. So once again, the biggest takeaway with direct variation is there is no y-intercept. No y-intercept. This is a proportional relationship with no y-intercept. If there's no y-intercept, what does that mean about every single line I'm going to have? What's it going to go through? The origin. Every single line that we were talking about will always go through the origin. Okay? Now, the letter K, you might want to take an estimated guess about what the letter K stands for, Stephen?
Rate of change.
Rate of change? I'll take that. There's another word. There's a specific word. It's the constant. Now, I know that you guys are very smart, and we all understand that constant does not start with the letter K. I don't understand why they chose the K. I'm sure it's from a different language. I'm sure in that different language, constant started with a K. Okay? Now, y equals the constant times x. Where does that look familiar from? Where have we seen something similar to y equals kx before? Zandon? Y equals mx plus b. So what I'm telling you is that this could also say y equals mx. Once again, no y-intercept. What I want to connect the dots here, though, is that the k and the m are the same thing. The k and the m are the same thing. We're all okay with that? Okay? Questions? No? Okay. Please put your watch up, Daniel. So now it says finding the constant. Identify the constant of the ordered pairs below. Then write the equation to represent the relationship. All right, so we're going to work through these real quick. Now, I showed you how to find slope multiple times. We're going to continue with that slope idea because when we do have a y-intercept, this doesn't work. The strategy I'm about to show you only works when we don't have a y-intercept. Does that make sense? Could you find the slope from this? How would you do it? Katie? Beautiful. Slope formula. This one right here. y2 minus y1 over x2 minus x1. Or like Hayden said, plug them in the calculator. Are we good there? Let me show you a different way to do it. You can also write this formula. Y equals kx. Do I have a y value? Do I have an x value? Okay, so let me show you this. I'm going to choose this ordered pair. I'm just picking it at random. You could pick any of these. 4 equals k1. Y equals k, x, x, x. We're all okay with that. Y'all, this is a one-step equation. I know the k is in front of the 1, but if I'm multiplying, does it matter what order I put things in? So don't we agree that I could also write this as 4 equals 1k? And that means the same thing? We're all good with that? Okay, if this is a one-step equation, how do I get k by itself? Luke, what do I do? I would divide it by the coefficient. What's the coefficient over here? So if I divide both sides by 1, 4 equals k. Now let me show you this though. Does everybody understand how I did that? I know it's the first time you've seen it, but is everybody on the same page with me? Now watch this. 8 minus 4. I'm still on this problem. Minus 4 is 4. 2 minus 1 is 1. You see how it still produces the same slope and the same constant? The only way that this one works, though, is if I don't have what? A y-intercept. Does that make sense? Questions, talk to me. You have to ask questions if you're confused. Because to me, I feel like it's making sense. Brian?
4 over 1 is the slope and the 4 is constant.
Yeah, don't you agree that 4 over 1 is the same thing as 4? Because 4 divided by 1 is still 4?
So do we write y equals 4?
Yeah, so here's how it would look. So then you would have your k is equal to 4. So what that means is whatever, I'll get to that. Hang tight. I'll get to that on these next couple problems. I just want to show you how to do this part, okay? Hayden.
So if you want, you can just divide y by x each time.
As long as there's no y-intercept. But think about yesterday's lesson. Didn't we talk about unit rate yesterday? And we had the amount of 15 lunches was $33.75. You guys remember that problem?
Yes.
Well, didn't I divide 33.75 by 15? Wasn't that y divided by x? Isn't that what we just did right here? See how it all connects? Biggest thing is, though, there cannot be a y-intercept. Okay, here's what I want you to do. For number 2, I want you to find me the constant of number 2. Find me the constant of number 2. The formula, y equals kx. Anybody get it yet? What'd you get, Charger?
Negative 1 over 2 equals k.
Negative 1 over 2?
I got 2 over 1 for some reason.
2 over 1? Negative or positive?
I don't know if I did it right.
Anybody got any different answers?
I got 9.
Steven got 9. Okay. Well, let's find this now. I'm going to choose this one right here. How's that? Okay. I'm going to do 3 is equal to k times a negative 6. Are we okay with that?
I did it wrong. I put the negative 6 as y.
Okay, so there's a difference there?
Yeah.
If I divide both sides by negative 6, then I end up with k is equal to negative 1 over 2.
Okay, I subtract. I added 6.
Okay, so you see it now? Other questions? They might not.
Multiplying by 6. I thought we were subtracting 6.
Got you. So look at my kx. There's no operation symbol being done there, right? So it's always multiplying. Just like mx plus b, Stephen, it's the same thing there, okay? Are we okay with this? Could you do the same thing with a table?
Yep.
Can I move past this then to the next section? Okay. Okay. For 5 through 13, it says identify the equation below that represents a direct variation. If yes, identify the constant of variation. Now, stay with me on this section. Let me check my time on video real quick. 11:21. I'm going to stop it.